Tangent. To graph tangent, let's think about how tangent of theta is always y over x. So here we have a unit circle and I have different coordinates. Where do you think tangent would be undefined? Good. Right here. And where else would it be undefined? Exactly, down here. The reason why is because you would have -1 over 0 down here, and you'd have 1 over 0. You cannot have 0 in the denominator. So that means tangent is undefined here and here. Okay, so what I'm going to do, guys, I'm going to put 0 in the middle right here. Go ahead and plot 0. From here to here is pi over 2. So I'm going to put pi over 2. And in the middle right here is pi over 4. I'm going to go backwards to this point. So I'm going to go negative pi over 4 and negative pi over 2. So what is the distance from here to here? Here to here. Pi, that's 180, isn't it? Okay, so guys, I'm going to graph tangent within pi. I'm going to complete a whole tangent cycle in pi, and I'll show you. It'll come together in a moment. Okay, remember, we said it's undefined down here. Before I get any further with you guys, I need y'all to understand that 3 pi over 2 is the same thing. I'll get in the same position if I subtract pi over 2. Okay? So this is the same thing as negative pi over 2. Okay? All right. So my distance is pi. That means I have an asymptote here, because we said it's undefined down here. And I have an asymptote here, because we said tangent is undefined there as well. Now, let's try to graph. Let's do this point right here. Tangent at 0 degrees. That's right here. So that would be 0 over 1, which is what? 0. So everyone put a point 0. Next, we're going to go to pi over 4. That is right here. The coordinate at pi over 4 is square root of 2 over 2, square root of 2 over 2. So if I put y over x, what will I get? 1. That's right here. Exactly, Ryan. All right, so down here at negative pi over 4, this is negative pi over 4. The coordinate is, let me write it down. The coordinate is negative square root of 2 over 2 and square root of 2 over 2. If you put y over x, what will you get? -1. So this is what your tangent graph looks like. This is what your tangent graph looks like. Thank you. Let me fix that. This one, the x is positive, the y is negative. There we go. We're still at -1 down here. Okay, now I just want to prove a point. You don't have to graph this, you can just look. If I continued around the unit circle, so far, let me highlight what we did. We started at negative pi over 2 and we went up here at pi over 2. If I keep going and make a full 2 pi, distance of 2 pi, let me show you what it's going to look like. So I'll keep going. Right here is, what is that? 3 pi over 4. Then this is pi. This is what? 5 pi over 4. And this is 3 pi over 2. And remember, it's undefined right here. So I'm going to draw an asymptote. So let me draw my asymptote. Okay, so guys, at pi, what is the value of tangent? 0. because this is 0 over 1, y over x. So that's 0. And right here, what is it? -1. Is that what y'all are saying? 3 pi over 4? So this is square root of 2 over 2 negative, and this is square root of 2 over 2. So you get -1, so that's down here. And what is it right here? Negative square root of 2 over 2 and negative square root of 2 over 2, so you get a +1. Do you guys see how it just made another cycle of tangent? Okay, so if you do all the way to 2 pi, like I did, I started down here. Let me clear this up so it's easier to see. I have so much going on right here. Okay. Let me clear it up so you can see it. I started down here, and I went a distance of pi, and that's my graph. If I go another distance of pi, there's my second string, and it'll just keep going. So guys, I can complete one full tangent graph in just the distance of pi. That's why my period is pi, not 2 pi. That's different from sine and cosine. So what you should have gotten from this part, this is a summary, a quick summary. Sine, cosine, cosecant, and secant, the period is 2 pi. However, for tangent and cotangent, your period will only be pi. Okay? Because if you go to 2 pi, you're going to get 2 of them. You just want 1. All right. Okay, continuing. Your domain is, where's your first asymptote that's positive? Uh-oh. It should be right here. Let me redraw it. Okay, let me fix that real quick. Pi over 2. So here's your asymptote. All right, so your first asymptote is at pi over 2. So we do not want to equal that asymptote. And how far is each asymptote? Exactly, pi. It's always going to match your period. So pi in. The distance between each asymptote is your period for tangent and cotangent. Okay? Because your asymptote is always at the beginning of your graph and at the end of the graph. So it's a whole period, the distance between the asymptotes. Your range is always going to be the same, -infinity to infinity. We did not have any vertical transformations or horizontal ones because we're just doing the parent function. Your vertical asymptote should match what we got for the domain, only it's an equal sign this time. And it's never decreasing, it's always increasing. Okay, now we're going to graph cotangent. When you think about cotangent, remember cotangent of theta, it'll be x over y. So guys, where do you think it's going to be undefined? Yep, right here and right here. So guys, I'm going to start here and I'm going to graph it till here. And I'm going to get a complete cycle. So I'm going to start at 0 and I'm going to go to pi. And I need 4 equal sections. So this will be pi over 4, pi over 2, 3 pi over 4, and pi. Those are 4 equal sections. Okay, it's undefined here. And it's undefined here. That means my asymptote will be along the 0 and along pi. All right. So guys, at pi over 2, you get 0 over 1, correct? That's just 0. So put a point at 0. At pi over 4, what will you get? 1. And at 3 pi over 4, what would you get? -1. So this is what your cotangent graph looks like. And cotangent, just like all the trig functions, it just repeats itself over and over again. So if you go 4 more spaces, 4 more sections, you'll have another asymptote, and it'll look like this. If you go 4 more spaces this way, you'll have another asymptote, and it'll look like this. Uh-oh, I crossed the asymptote. All right, guys, let's answer the questions. Your domain, you have an asymptote here, and what's the distance? Yep, it's a distance of, the next asymptote is a distance of pi away. So it'll be pi in. Your period is pi. Range is always the same. Uh-oh. Your range is always the same. We did not do any vertical or horizontal transformations yet. Your asymptote is always going to be the same as the domain, just with an equal sign. And we didn't increase on this one, we decreased. All right, guys, this is the first transformation we're going to do, tangent 3x. So remember, guys, tangent and cotangent, the period is pi. So that means your formula will be pi over the absolute value of b instead of 2 pi over the absolute value of b. Okay? So for our example up here, to find the period, I'm going to do pi over the absolute value of 3, which is 3. So my period for this example is pi over 3. Okay, continuing to look at this, guys, did it shift left or right? No, so we don't have to worry about that, and it didn't vertically stretch. All right, what do I always do to my period? Divide it by 4 to get equal parts, correct? I need 4 equal parts. So I'm going to do pi over 3, and I'm going to divide it by 4 equal parts, right? So the way you divide fractions, you flip the second one, and you multiply. So I get pi over 12. Uh-oh. So each section is going to be pi over 12. So how I'm going to do this, I have 4 equal sections. So here's a section. This is a section, this is a section, this is a section, this is a section. My middle is at 0. That means this one is pi over 12. This one's negative pi over 12. I need to go over pi over 12 again to get this one. This will be 2 pi over 12, which is just pi over 6. So that means this one's pi over 6. Each one of these is pi over 12 apart. Okay. Just as a reminder, guys, your parent function for tangent always straddles the y-axis. You guys see that? Tangent always straddles the y-axis. So that's why I drew it like that. Okay, so my asymptotes will be here and here. And my point is there, there, and there. So that's what my graph of tangent looks like. If you want to make sure, you're not sure if that's correct or not, I can always help you believe more by plugging in a number. So I'm going to give you the original problem. The original problem is tangent 3x. But instead of an x, I'll plug in pi over 12. Okay, well, this simplifies to pi over 4. And tangent at pi over 4 is square root of 2 over 2 divided by square root of 2 over 2, which is 1. And that's exactly what I have on my graph. Now let's answer the questions. Your domain. X cannot be this asymptote, which is at pi over 6. And what is the distance between each asymptote? Pi over 3, because that's your period, pi over 3. So put pi over 3 in. And your vertical asymptote equation is the same thing without the not equal to symbol. Range is always the same, and we were increasing, not decreasing. If you remember from the parent function of cotangent, the asymptote is here, and it goes like this. That is the graph for cotangent. That's the parent function. However, our b value is 1/2. So we have to do pi divided by 1/2, which becomes 2 pi. So this period is 2 pi. So that means I graph this entire thing from 2 pi, and I'm going to split it into 4 equal parts. So this is pi over 2, pi, 3 pi over 2, and so on. All right, so that's my graph. You can make your points more exact. It should be there and there. So I'll draw it better. Okay, so our domain, your first asymptote is right here on 0. So you cannot be 0, and the distance from here to here is 2 pi. So 2 pi in. You cannot be 2 pi in. Your vertical asymptote is the exact same thing, but with an equal sign. We did not shift left or right. We did not stretch. Your range is always the same. And I'm sorry, guys. Can y'all spot the mistake? Yes, what?
It's split.
Yes, cotangent should look like this. So make sure you have it correct. What did I graph, guys? I graphed tangent. So if I had tangent of x over 2, that shifted over to the right pi, then that would be the graph that I drew. Because remember, tangent, that's the x-axis. Well, this is the y-axis. It looks like this, but I drew something right here. So that means it shifted over pi. My apologies. Cotangent, you always space to the top and then you come down. Okay. So I'm not increasing, I'm decreasing. Is everyone okay with this graph? Okay. Let's do a harder one. Let's do this one. We have a reflection. Okay, so again, guys, I'm sorry for my previous mistake. Cotangent is graphed like this. It's facing down. Okay. All right. So let's graph this. Cotangent, we need to figure out the period. So to do the period, you do pi divided by this b value, which is 1/2. So that means your period is 2 pi. So I'm going to put 2 pi and split it into 4 parts. That'll be pi over 2, pi, 3 pi over 2. Your asymptotes are always at the beginning and the end. Okay, so that's how it would normally look for my period. However, I have a shift. It goes to the right. It shifts to the right by pi. Shifts to the right pi. So guys, I'm going to go advance a pi. So it looks like pi is 2 little spaces. So I need to go over 2 little spaces. Does that make sense? Okay. I need to go over 2 little spaces. So that means my asymptote, I need to move them over 2 spaces. So my asymptotes are now here and here. We didn't move up or down, so my midpoint is right here at 0. However, my amplitude is 2 and I'm reflecting. So normally, guys, cotangent looks like this, but since I'm reflecting it, it'll look like this. So I'm going to go up 2 points since my amplitude is 2 and down 2 points. So this is what my graph looks like. Your domain. Where is your first asymptote? Pi. And what's the distance between this asymptote and this asymptote? 2 pi. It's always the same amount as your period. So plus 2 pi n. That is going to be the same equation for your vertical asymptote. But don't put a slash like I just did. Only put an equal sign because your vertical asymptote is equal to this pi. And every asymptote 2 pi away. We shifted to the right pi and we shrunk by 2. I'm sorry, we stretched by 2. And there was also a reflection in there. And am I increasing or decreasing? I'm increasing. Normally for cotangent, you're decreasing. However, we reflected, so now it looks like that. Here's the next transformation. My b value is 1/2, so you do pi divided by 1/2, which is 2 pi. That is my period, 2 pi. So I'm going to put 2 pi and split it into 4 equal parts. All right, what's wrong with what I did? You said what? I'm supposed to be on the negative side, perfect. Because remember, guys, cotangent straddles the y-axis. So if you did this to start off with, you're already going to get it wrong because what are you graphing? Cotangent. For cotangent, you start here. For tangent, you start here. All right. Okay, now let's talk about the shift. What is my shift? We're going to the right, pi over 4. So guys, normally your asymptote would be here and here. If I shift to the right pi over 4, it's going to be right here. Do you guys see that? Okay. Because from here to here is pi over 2. So half of that is pi over 4. So guys, I'm going to draw my new asymptote correctly. Since I have a shift, it's going to be where my little red ticks are. So my asymptotes are going to be here and here. Okay. And since I shifted in the middle, normally my middle point is right there, but I shifted here. So my middle point would be there. Okay, so I'm just going to put a little tick mark so we know where we're going to put our middle. Our middle is now right here because we shifted every single thing to the right by pi over 4. Okay, now let's talk about some different things. This is my midline. My midline is at 1. So guys, right here is your midline. That's where I'm going to put my starting point. Your amplitude is 3. That's your vertical stretch by 3. So I'm going to go up 3. 1, 2, 3. Right here. And I'm going to go down 3. 1, 2, 3. Right here. So this is your graph. Let's talk about your domain. X cannot be, your first asymptote is right here at, what is this? Between pi and 3 pi over 2 is 5 pi over 4. So that's 5 pi over 4 plus, what's the distance between each asymptote? 2 pi. It's always the same as your period. So 2 pi n. Your vertical asymptote equation will be the exact same thing, but with an equal sign. And we shifted to the right pi over 4. Your range is always the same. This is increasing, not decreasing. You can keep working. I'm just going to solve this one on the board. And as you're working through it, you can check and see if you're right or not. So guys, normally my asymptotes are right here, but it shifted a whole period. It shifted the whole period. The period is pi over 2, so it went a whole period to the left. A period is 4 spaces, right? So I just went over 4 spaces and just drew it again. My midline's at -2. That's why my center point is on -2. And my amplitude is 2. So I just went up 2 spaces here, up, down 2 spaces here. My asymptote is still this first one, pi over 4, because you guys, tangent just repeats itself. So there's also an asymptote 4 spaces right here. There's an asymptote 4 spaces that way. So this is the first positive asymptote, so I just use that one. If you wanted to, you can use this one. Okay. If you wanted to, you could also use this one, but let's just start with the positive because I don't want to grade a whole bunch of different answers. Okay. So you're not wrong. So if you chose this one as your asymptote that you want to start on, then that means your domain cannot be, this is at negative pi over 4 plus the distance is pi over 2n. That's also correct, but let's try to be uniform. So let's just pick the positive one, okay?